Question 2. Find the zeros of each of the following quadratic polynomial. Find the zeros is like number 1. We have to find the value of x, whether 1, 2 or 3. That means we have to do by factorization. The methods we already discussed in equation 1. And here there are two parts. The first part is to find the zeros. The second part we have to verify the relationship between the zeros and their coefficient. We have to see the formula as to say between those two. That means those value which we get after we split like number 1, are they in relation or not with the coefficient. You already know, okay, quadratic polynomial, we used to write it in this form: ax square plus bx plus c. Then here you will see a is the coefficient of x square. They say, no, verify the relation of the coefficient and the values or the zeros. So here we have to see, we have to compare the values what we get from here and a, b and c, what kind of relation they have. Okay, so remember this is the standard form of quadratic polynomial. So a will be the number present with x square, or we call coefficient of x square. Then b is a number present with x, that is a coefficient of x, and c is the constant term. So sometimes those value of x which get from here, we used to denote them as alpha and beta. These are the Greek alphabet. Okay, Greek alphabet, this one we call it alpha, this one we call it as beta. So there you see the relation which we have between this one and the coefficient. It goes like this. These are the formulas you have to remember yourself. Okay, sum of zeros, that means if we plus alpha and beta, it should be equal to minus b by a. B is the coefficient of x, already mentioned here. A is the coefficient of x square. Then another formula, that is product of zeros. Okay, that means if you multiply alpha and beta, then what we should get? It should be equal to c by a. So c is what? C is the constant term. A is a number present with x square. That means we have to find, okay, this one, the sum of those value which we get, are they equal to minus b by a or not? If they are equal, so verified. If they are not, then not verified. Okay, we have to we have to verify both the sum and the product. Those value which we get, replace it here, and then the coefficient replace here. Then we will see are they equal or not. So let us continue with question number 2. Then in case, if suppose, okay, for another question, if they give you the sum and the product, you may have to find the quadratic polynomial. Then in that case, you can simply replace here x square sum into x, then product of zeros. Or if they give you alpha plus beta, the same way, x square minus, here you replace after you add them, here you replace after you multiply them. So let us see question 2.1. Okay, here we have 3x square minus 2x minus 1. So first we have to find the zeros, then after that we will do the verification. The number present with x here is 3. With x square, I mean with x it is minus 2, that is b. Constant term is minus 1. So first we will split middle term. So we will multiply a and c. A, you know, it is equal to 3. C is equal to 1. The sign we will check later on. Okay, so we need two number. 3 into 1, 3. We need two number. If you multiply, we should get 3. Then here what sign you have? You have minus. Then what number in the middle? We have 2. 2 number, if multiply we get 3. If we minus, it will be 2. So what are those number? We have no other, only 3 and 1. 3 into 1, 3. 3 minus 1, 2. So let us quickly split it. Now I'll do quickly because I hope you already know how to split middle term. So here 3 minus 1. Always make a habit to write bigger one minus small. Okay, this one sign will come from here. Then minus 1. There you will have 3x square. What to do? Remove the bracket. 3x minus to minus plus 1x minus 1. Then here you have to take common. There you have 3x square. Here also 3. No, we have put 3. Here you have 2x. Here you have 1. So we take common 1. 3 already put here. 1x already put here. We are left with 1. Then minus. This side we take everything. So we are left with 1. Then plus. Here you have 1. Take common 1. Inside we are left with x minus 1. So these two, they are same. Take common. Then the other one you can write 3x plus 1. So to get the zeros, we can write let p of x equal 0. So that means x minus 1 whole 3x plus 1 will be equal to 0. So we can write either x minus 1 equals 0 or 3x plus 1 equal 0. This is minus. Take that side, will become plus. Then this is plus. Take that side, become minus. We want only x. So number which is together with x, because here in 2, if you take that side, it will become divide. So now we get the zeros. Next step, we have to verify. Remember, the question already say verify the relation between the zeros and the coefficient. Coefficient we already have here. Coefficient of x square is 3. That of b is minus 2. That of c is minus 1. Okay. Then the zeros, you have them here. 1 minus 1 by 3. So we will take them. Okay. We'll take this one as alpha. Then this one as beta. So remember the formula. From the formula we already have sum of zeros. It should be equal to minus b by a. We have to see that these two are equal. Okay. Sum mean what to do? We have to plus alpha plus beta equal to minus b. B already have no from here. Equal to minus 2. Then a we already have from here. It's equal to 3. Then now in place of alpha we can replace with 1. In place of beta we can replace minus 1 by 3. Then here we have minus to minus plus. Then here we have 3. Once you have fraction, what to do? Remember, we have to find the LCM. LCM of 3 and 1 will be 3. So you can take by the side the fraction into LCM. 1 divide 3, 3. 3 into 1, 3. Plus into minus, minus 1 by 3 into 3. 3 divide 3, 1. 1 into 1, 1. So we have 2 by 3. 3 minus 1, 2. 2 by 3 equal 2 by 3. Are they equal now? Yes. So for the sum we verified. Next we have to verify it for the product. Product also you already know. Product of zeros. From the formula we have it as C by A. Product mean what? Multiply. The zeros we know alpha into beta. C you already have from here. C is equal to what? Minus 1. A equal 3. So there we have minus 1 by 3. Okay. Alpha from here we have 1. Multiply beta. Beta we have minus 1 by 3 equal to minus 1 by 3. 1 into 1, 1. So you see, are they equal or not both sides? Okay, so we see that both sides are equal. So we already verified. Remember, alpha, beta we get from W of x, which we calculate after splitting middle term. Then this is sum of zeros equal minus b by a is a formula. Product of zeros equal c by a. C, a you already have from here. A, remember, a number present with x square. B, a number present with x. C, a constant term. So we have to prove that left hand side equal to right hand side. That means the zeros which we get, they should be equal to the coefficient of the given numbers. So we see that in both cases they are equal. So in that way we verified it.